Hello everyone, this is Shruti and my seminar topic is manufacture applications and hazard in handling of caustic soda. So, let's start the topic. Three modern sodium hydroxide manufacturing methods. These are the three modern sodium hydroxide manufacturing methods are given. So let's start. Sodium hydroxide history. So sodium hydroxide means NaOH, an inorganic compound with following synonyms. So caustic soda, lye and sodium hydrate. So NaOH widely used inorganic industrial chemical. NaOH is having certain properties like sodium hydroxides. Chemical formula is NaOH. NaOH molecular weight of 39.997. So mole and sodium hydroxide is certain pH of -12 and -14. So these are the sodium hydroxide so information. So next one is the sodium hydroxide characteristics. Sodium hydroxide characteristics can be mentioned as raw materials for various industrial products. So cope product in chlorine synthesis, strong base, highly corrosive and auxiliary chemical. Ordinary material caustic soda is available in two forms: caustic soda lye and caustic soda solid. Solid form caustic soda can be in the form of caustic soda flakes or caustic soda granules. So next one is the pure form of sodium hydroxide, also available as sodium hydroxide pellets and sodium hydroxide flakes, sodium hydroxide granule, sodium hydroxide solutions. So these are some characteristics of sodium hydroxide. So next one is the industrial applications of caustic soda. Caustic soda has wide variety of industrial sectors like in pulp and paper processing industry. Caustic soda used as the stages like bleaching processes, in delinking of waste paper and in water treatment. So these are the we can use it as a industrial, so like this. And next major industry like textile industry, caustic soda is used to process cotton and synthetic fibers. So we can see in this sentence we can measure industries like textiles. So used the caustic sodas for cotton and synthetic fibers. So next one is the caustic soda is utilized more in the soap and detergent industry. Caustic soda are most used and most utilized that the soap and detergent industries. So next one is the other caustic soda uses include. So how can it uses in another way? We can see that in oil and gas industry to remove pungent smells. When gas or oil industry to remove pungent smells. In household cleaning products we can use that caustic soda, and in beverages bottles we can use the caustic sodas are applied, and in home soap making there is also caustic soda are used. So next one is the three sodium hydroxide manufacturing methods. So next one is the sodium hydroxide solutions are produced by three different technologies like mercury cells, membrane cells, diaphragm cells. These are the different technologies are produced. How? Next, see the next one. Each of the above processes utilize sodium chloride NaCl salt as the primary raw material. Electrolytic splitting of salt results in products like chlorine, sodium ion in term Na, will react with water in the mercury cell to form sodium hydroxide and hydrogen as byproduct. So next one is the mercury cell. What is that mercury cell? We can see that this diagram. So anode, cathode. So these we can see neatly in this diagram how can it works. So next one is the in the mercury cell processes saturated brine uses down a steel through roughly 15 meters in length and 1 meter wide between a streaming film of mercury, the cathode, and the titanium plates. This means anode. Direct current is connected between the anode and cathode. So correctly between the anode and cathode are arranged. So next one is the chlorine freed at the anodes gathered above the brine and is begin as a hot, wet or corrosive gases are applied. So next one is the sodium ions are released at the surface of the streaming mercury cathode. So sodium ions are is there. So its surface on the streaming mercury cathodes are formed. So next, forming an amalgam of low concentration with the mercury which streams out of the cell without reaching with the water or chlorine. So these are clear. So next one is the mercury cell. Thus has two products are give, and first one is the hot wet chlorine. So next one is the sodium amalgam. So next point is the soda cell or decomposer is a cylindrical steel through located with graphite balls, so or graphite electrodes. Graphite electrodes, and the sodium amalgam is passed. When the sodium amalgam is passed along with the pure water, we can pass that into the decomposer, where it reacts to transfer sodium hydroxide as a controlled sodium. When its hydroxide is passed, when controlled 50% of aqueous solutions are controlled. So next one is the and hydrogen gas liberating. When a hydrogen gas is liberating, free mercury with is reduced. When its mercury is liberating, so which is reduced against the electrolytic cell in the cell to reduced. It reduced totally. So next one is the graphite provides a surface that expedites this reaction. So next one is the following two types of reactions called brine cell and the soda cell respectively. Brine cell formula and next one is the soda cell. How can it? We can see this sentence. So brine cell 2Cl is equals to Cl2 plus E sodium. So sodium chloride. So how can it work in brine cell? So next one is the soda cell. So sodium water NaOH. So we can observe in this. So next one is the second method is the diaphragm cell. So this is the diagram. Chlorine gas and hydrogen gas, a methanium anode and steel cathode. These are the two anode and cathode. One is the sodium and another one is the hydroxide OH. So next one is the H2O. These are the waters and substrators diagram. This is the middle one is the substrator diaphragm. So this is the brine containing sodium hydroxide. This is the brine. So how can it enter and how can it exit? We can see this in diagram. So next one is the diaphragm. So this method products 71% of a sodium hydroxide. Diaphragm cell processes utilizes substrators or alternate substitutes to substrators to separate the co-products sodium hydroxide, caustic soda. This means caustic soda and chlorine, the production of 50% of NaOH occurs primarily outside of the electrolytic cell. So next one is the diaphragm cell products a very weak cell liquor. So diaphragm cell product, this means, so this is the weak cell liquor. Okay, so next, that contains 12 to 14% by weight. This means 12 to 14% of weight is there. So next, NaOH and the constant volume of NaOH, NaCl salt, sodium chloride salt, the cell liquor is subsequently evaporated in a 3 or 4 effect of evaporations method to a final normal concentration of 50%. So next one is the NaOH of by weight. This weight is the evaporation. How can it in 50%? We can see that in next. So this surplus salt is precipitated and filtered through the evaporation method for subsequent recycles. So this method produces the lowest quality electrochemical NaOH solutions are formed. So this is the diaphragm cells. So next one is the heat quality considerations with respect to the diaphragm cell products. Caustic solutions include comparatively high salt, chlorates, carbonates and sulfatates. So salt, these are the salts. So as a sodium chloride concentration are typically 1.0%. So in a NaCl concentration is the 1.0% with maximum reasoning from 1.1 to 1.3 weight percent containing or producer. Okay, so next one is the diaphragm cell creates caustic soda. The diaphragm cell is created caustic soda, means a NaOH is usually referred as a diaphragm cell grade. It is conjointly known as comparative grade, technical grade and occasionally technical and diaphragm or other similar combinations. So next one is an additional grade of caustic soda produces by the diaphragm cell method. In the substrate grade, the production of sublimate grade involves the further evaporations of the 50% of diaphragm grade NaOH solution to cut back the salt concentration. The higher concentration solutions is then diluted to the 50% of concentration that is commercially available as sublimate grade caustic soda. So next one is the common uses includes processes and severe water neutralizations. We can common uses that, and textiles productions also common uses, and soaps, detergents, these are common, and aluminium production, there is also a common use at the caustic soda of aluminium production. These uses or applications typically can confer with the caustic soda as any of the varied grades we can that can use. So next one is the third one is the membrane cell. We can see in this diagram fresh brain and brain concentrator. So next one is the chlorine gas and hydrogen gas. How can it liberated? So next one is the caustic minimum anode and nickel cathode. So anode, cathode, these are the ion exchanger membrane is also there, and pure water, how can it work, and sodium hydroxide and 33%, how can it. So next see the membrane cell information. So membrane cell information, these method produces approximately 13% of a sodium hydroxide is and the membrane cell methods utilize a selective membrane that separates the chlorine and sodium ions. The membrane permits the sodium ion to migrate across the membrane, whereas keeping the chloride gas and the salt solutions in a compartment on the opposite facet of the membrane. The sodium ion is reacted with refined water as within the mercury cell to produce the caustic soda, means NaOH. Evaporation is employed. So next one is the evaporation is employed is within the diaphragm method. In diaphragm method we can see that to lift the concentration up to the nominal 50% weight, 50% solution. The salt concentration are not targeted as considerably during this evaporation method, attributable to the selective diffusion nature of the membrane, as well as the produced quality of evaporation needed during this method opposed to the diaphragm evaporation. The caustic soda produces by the membrane cell. How can it's in a membrane cell the caustic soda are produced? Means it most typically bright up as a membrane grade. These are the membrane grade. It consequently contained a growing acceptance as a Royan grade product in all areas outside a Royan fiber production. These are the information of the caustic sodas. So thank you one and all. Thank you.